Hello everyone, this is Rahul from RDS Bangalore team. Today we'll be covering the topic failover in PostgreSQL. Let's quickly move on to the agenda. We'll be covering the below topics, like we'll be going through the introduction of failover, like why you need failover. Then we'll deep dive into PostgreSQL failover. Then we'll see the types of failover, like manual or automatic failover, both way you can set up. Then we'll have a quick demo how failover is done. Then we'll move on to how failover is done in RDS. So these are the quick points we'll be covering. So let's move on to the introduction. So failover is a mechanism which helps in running database service with uptime approximately 99.99%. It's like you can have your database running almost like 24 by 7 365 days, but there is always a chance, like 0.01% of chance, that something may go wrong. So that is why I've written 99.99%. For example, a banking application uh, is such an application where bank cannot go offline unless and until it's in scheduled downtime. So you can understand how important a database system is. It cannot go into a downtime. So failover is important in that scenario, like where you cannot have a downtime. Still, sometime you need to change your hardware. Like it may be a scheduled change, or it cannot be. Sometime it's like emergency change where you need to change your hardware. So like we know, like database is hosted over in hardware, and every hardware have some age. So we need to failover at times to a new hardware without any downtime. That is the place where failover comes into place, and it's very important in that scenario. So to maintain the maximum uptime, failover is one of the important mechanism which can be adopted manually or it can be automated, so that the application is effective with very little downtime, which is like 0.01%. So this is all about introduction. Let's quickly move on to more detailed how failover like really it looks like. So what does failover mean? Failover, it means that standby DB server can be brought up anytime during an outage. So in normal any production environment, we can see that there would be there would be master and slave, which would be connected. So slave is the server which is a backup of master in real time. So whatever like transaction happens in master, it automatically goes to slave. So it's a real time backup strategy which is uh, which every production environment always have. So we can look into the diagram and figure out. And so you can, the right hand side, you can check how normal operation is happening. So there's a master, there is a slave, and there is a replication going on. So everything is running perfectly here. So any point of time, if something goes wrong in the master, what will happen? So all the connection which are coming to master, so that would be affected. So that is the very important thing, that so we should have a real time backup, so that immediately the application can be pointed towards the slave, so that the application runs smoothly. So that can be automated to move your application to slave, or that can be done manually. So this is the only possibility in Postgres, like you need to move the thing from the master to slave. So it's not like if any instance goes down, so it's it will have some amount of downtime. So that amount of downtime is to point your master application. The application is pointed to a master, that how much time it's needed to point it to the slave, that much is only the downtime needed in Postgres. So that is why we recommend Like your failover server should be exact the same configuration of master, so that if any point of time you need to failover to a standby server, it should be able to handle the load. So that is what like high overview about a failover. So next we'll be seeing like few points which I've already covered. See, like we assume that there is an active replication between primary and secondary, so that during the time of failover, so already the failover server should have all the transaction, so that after a failover is done, a customer should not, uh, a client or a customer should not complain my data is not there. So that any point of time there might be some issue in primary, so that point of time it is a failover is done to the secondary. So if you like how failover happens in Postgres, if you see technically in the background, so we create how it is done, like we do the replication. So there is something called recovery.conf file where you mention a trigger file. So that trigger file is nothing, that file is only mentioned the recovery.conf file, so that if you want to make your standby server as master, we just need to touch that file, I mean to create that file. So you just touch and that file name which is written in the recovery.conf file. So that you need to, I'll show you all these details in demo how things are done. So meanwhile we just go through the theory part. And as resulting it will make the secondary server as read write. So after you touch that file trigger file, it will make the secondary server, the slave server, as a read write. Normally it is only in select in only in read mode. So after you touch that file, it makes the secondary server as read write, and it will stop the replication between the primary and the secondary DB server. So after that only we need to change, we need to point the application towards the slave. Before that we should not do the changes. So that changes also can be done automated, in an automated way, like how your application should point from, if something goes wrong in the master, how application should point to slave server. That also can be automated. Also you can do it manually if your production system is not that critical. So we have like different types of failover, like as I said, like there's something called manual failover, there's something called automatic failover. So these are the different types of failover. In manual failover again we have trigger based, like we create we touch that file, trigger file, and it also can be promote based. So just to remember this, these are the two types. I'll show you what is trigger based and what is promote based, so that you can have a better understanding about the difference between them. So and the automatic failover, it can be done through a script. It can be either Perl script, it can be an uh, shell script, or we can use the automated third-party tool. EFM is a tool from Enterprise DB, like EDV failover manager, or else we have seen in some of the previous session about PGPool 2, that also does a automatic failover. Also there is a replication manager from second quadrant. The last one is script, your own script. So in the so let's see all this manual failover and automatic failover in more details way. So first of all, trigger based. So this is the uh, manual failover, one of the type of manual failover. So where we have the recovery.conf file, that is a configuration file in the secondary server, and we define the trigger file inside the recovery.conf file which is in the secondary server. We define the location where you need to create the trigger file. So as soon as you create the trigger file in secondary DB server, automatically the secondary server will promote as primary, and it will be in read write mode. So that is how a manual failover is done. So just touch that trigger file and your failover is done. So in through script you just you can say that every 10 seconds it will like okay, will come about the automatic failover in the next slide. In promote based you need not touch that file. So how you start the server, like through pgctl command you start the server. So instead of like you give pgctl, you give the data directory name, and at the end you write promote. So at the in the backend it does touch the trigger file. So that is how like promote based manual failover can be done. So it writes, if whenever you write promote at the end instead of start or restart using pgctl command, in the backend it does like create a new failover file only. So that is a different types of manual failover. So let's see about the automatic failover. So automatic failover, it's like as I said, like you can have your own script, or you can do through some few tools. They are like very good tools like EFM. It's an enterprise DB failover manager, rep manager from second quadrant. PGPool is independent. So we need to install those tools, and after configuration, we just mention that uh, if you find that your primary server is like not working for 10 seconds, you can define the time. Like if it is not reachable from 10 to 60 seconds, then you do a failover. In the backend, it does the same thing. Either it does a promote or it create that touch file, a trigger file. In the backend, it does the same thing through that tool. So this here in automated failover, in the backend the process is same, but they do the things with the tool. So the backend either they'll do a trigger based or promote based to make the failover happen. So now let's like have a quick demo how we can achieve the failover. So I have already set up streaming replication, and I have done all the changes. So I'll just show you how a failover is done. First of all, let me go to my uh, terminal. Terminal. So already I have settings. I have the replication, active replication. You can see this is my master. It is streaming, and this is my slave where it is recovering. So I have active master slave configuration already. So I'll show you like what is there inside recovery.conf file, like what is that trigger file. If you go to, you can go directly to slave, directly you can go inside and not directly vi user local PostgreSQL data slave. So we'll be seeing the recovery.conf file. So here you can see the trigger file. You just mention a path for the trigger file. So if you just trigger this file, just create this file. So that will stop the replication first of all, and then it will do a read write mode to the slave, and your failover is done. Now if you log in uh, just to the master, so this is a master, and to log into your slave I use 5433. So this is my slave. If, to check it is slave or master, you can use this command, which is true. You give this commands like pg is in recovery, it's in function, it is saying true. So this is your slave. Now you try to create here test, you won't be able to create, cannot execute create database in read only transaction because this is your slave and it's only enabled for read only transaction. But you can do any select here, like if you have any tables here, like if you do, I'm not sure we have records here, so you're able to do some test. Okay, so let's do a failover. Let's do a trigger based failover. So just so we'll just touch this file, that means we'll just create this file and it will do a failover. So touch, this is the command we type and just press enter. So it created a trigger file. Now we can check, now we can see that active replication is broken and your slave server is in read write mode. Now if you see pg in recovery, it should say false. See, it is saying false because this is your primary. Now it can do any transaction. Now create database test new, it should create a new database. So in slave we are creating the new database now. So this is all about like how you do a failover through trigger based. So again, so I'll show you how you need to do a failover using a promote. For that again I need to set the replication. So it would take at least few seconds to reveal my replication. I'll just deleting my data slave, that means my slave. Before that let me stop the service. Pages, sorry, let me go to pin. I'm giving my data directory name. First I'm stopping the server so that I can delete. So it is stopping my slave server. Now I'll be deleting my data directory for slave so that I can rebuild it. So I'm removing, I'm not sure I'm in the correct directory, so I need to go here and remove. So I'm going, I'm just rebuilding my slave so that I can show you how promote based is done. So you can see here there will be something called data slave. So I remove my slave, again I will create data slave. I have to change the permission. Then I'll copy a few things. And data, I'm copying my master data to data slave. So it should copy my entire data directory. So I'm just building a replication. So that won't take more than should not take more than a minute. database is heavily loaded. So I'm done. So before that I should go to data slave. Before starting my instance, I should go to data slave and I should remove few things like postmaster, because it's a postmaster is of master, and I'm renaming few of my configuration to, to the original name. So now I should start my instance. My so I'm starting my instance, my slave instance. Now we can check if application is on or not. You can see again one more application is on. Now let's log into slave. You can check through this command preview recovery, it will show true because it's in standby server. So now let's do an promote failover. So it's very simple. Like I'll be using the same command which I used for starting. Slave and promote. I'm promoting my standby server uh, as a master. So I think it's done. Let's look quickly, look and check. Now it's false. Now we can create a table here. Data base test 111. So this is promote based. I don't have any automated script of mine, so I won't be able to show you more about automated failover, but you can create a script, small script, shell script, so which will show you which will show you how automated scripts are also helpful, but at times it become crazy. We need to figure out in the script if something goes wrong, so it's better you do a small manual failover, always just a single command. So we have seen the demo how trigger based and promote based uh, failover is done, keeping in mind that streaming replication was in place. So now let's see failover in RDS. Failover in RDS acts differently. They're not they're not like whatever I have described before. They are like multi-easy concept where like they have two different instances in different AZ, and if something goes wrong in one instance due to some underlying hardware, it does a failover to the second server, like the standby server. But in multi-AZ, you cannot. You have only access to a single server, that is a master. To your failover server like this, to the second server where a failover is done, that server you don't have access. But uh, instead of that, you have something called read replica, which is a replica of like master and a replica of master. But you cannot do a failover from master to a read replica. The place where you can failover is like multi-AZ concept, where it automatically something goes to wrong with one instance, it goes and failover to the second multi-AZ server. So it's something very different in RDS. So that's how things happens in RDS. So We almost came to the end, so let's wind up the summary. Like failover is a mechanism in database instance so that application is always up and running with very less downtime, like 0.01, the time it takes to point your application from master instance to slave instance. And there are several ways we can do a failover in Postgres. It can be manual or it can be automated way. We have seen the manual way how things are how things are failovered. And failover in RDS is automated where primary server failover to standby service happens if there is any issue in primary server. And there is something called PG Rewind. It's a new tool in the newer version of Postgres, which helps failover master to get sync with the new master. So now we have seen that we have done a failover. Again, we had to build the slave because it can't sync after you break the application. But PG Rewind is a new tool which was introduced so that you can sync after a failover is done. And automated failover is we can achieve it using tool like EFM, pgpool, rep manager. It is a very three tool used worldwide. So we have come to an end. So if you have any queries, please free to contact me at RSSAHA. It's my alias. And I hope this session was informative and helpful for you. Anytime you can contact me for any other assistance. Thank you for watching this video.